take a look at this problem. We got tangent squared equals negative 3/2 secant. And we want to solve this on the interval 0 to 2 pi. Well, let's think our Pythagorean identities. Remember, we have our sine squared plus cosine squared is equal to 1. And if I go through and divide everything by cosine squared, sine squared divided by cosine squared is tangent squared. Cosine squared divided by cosine squared is 1. And 1 divided by cosine squared is equal to secant squared. Well, remember, one technique is we try to get everything in terms of the same trig function. So I can rewrite the tangent squared in the following manner. I'll take that 1, move it over the right side, and we got tangent squared is equal to secant squared minus 1. So we can come up here, replace tangent squared with secant squared minus 1 equals negative 3/2 secant theta. Now I'm going to move that over. So we're going to have secant squared theta plus 3/2 secant theta minus 1 equal to 0. Now that would be kind of hard to factor, but let's get rid of the fraction and see what we have. So I'm going to multiply everything by 2. So I got 2 times secant squared plus 2 times 3/2 secant plus 2 times negative 1 equals 2 times 0. So that gives us 2 secant squared. Those 2's cancel, so we've got 3 secant theta. 2 times negative 1 is negative 2, and 2 times 0 is 0. Now to see if this will factor, I'm going to replace my secants with a variable. I'll do it over on the side here. So that gives us 2p squared plus 3p minus 2. And that factors in the following manner. 2p minus 1 times p plus 2. Let me just double check that. 4p minus 1 and then minus 2. But we weren't really dealing with p's, we're dealing with secants. So I'm going to replace the p here with secants. So this becomes 2 secant theta minus 1. And this is secant theta plus 2 equals 0. Well, now we can apply our zero factor property. Zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set 2 secant theta minus 1 equal to 0, and I'll set secant theta plus 2 is equal to 0. Now we want to solve for secant, so in this one I take negative 1 over, and we got 2 secant theta is equal to 1, divide both sides by 2, and you get secant is equal to 1/2. Now we got our our trig equation works best if we can put it in terms of sine and cosine. Secant I can rewrite as 1 over cosine equals 1/2. Remember, if you have a single fraction equals single fraction, you can flip both of them. So we've got cosine over 1 is equal to 2 over 1. And we got cosine is equal to 2. Now remember, cosine bounces back and forth between negative 1 and 1. It never equals 2, just our basic function. So that's just going to drop away. Now over here I'll do the same thing. I'll take the 2 over, becomes a negative 2. I'll rewrite secant as 1 over cosine. And negative 2 I'll rewrite as negative 2 over 1. Now if you got a single fraction equal to single fraction, again you can flip both of them. So this is cosine theta over 1 is equal to 1 over negative 2, or cosine theta is equal to negative 1/2. Let me think this through. Let me see. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, or 2 pi over 3. 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, or 4 pi over 3. And then this would be, that's 8 pi over 6, 9 pi over 6, 3 pi over 2. Okay, that checks. Now this point right here would be negative 1/2 square root of 3 over 2. And this point right here would be negative 1/2 and negative square root of 3 over 2. Now we're looking where cosine is equal to negative 1/2. Cosine, which is our x part of our point, is equal to negative 1/2 there and negative 1/2 here. So theta is going to equal to 2 pi over 3 and 4 pi over 3. Maybe. 2 pi over 3 and 4 pi over 3. Let's check these. And I'm going to do it the lazy way. Do it on my calculator since I don't got any room here. I want to make sure I'm in radians, so press mode, and I am in radian measure. So do second mode to exit out. And let's see what tangent theta squared gives us. So I'll do beginning parentheses, tangent, and then 2 pi over 3. So 2 second caret, divide by 3. Closing parentheses on 2 pi over 3. Closing parentheses on tangent, and then I push my x squared. And press enter. And that gives us 3. Works out interesting. And let's plug it in this other side. So we're going to have negative 3 divided by 2 times secant. Well, we don't have a secant, but secant is 1 over cosine. So I'll do 1 divided by cosine of 2 pi over 3. So 2 and then second caret divided by 3. And enter. And that gives us 3. So that checks. Okay, let's do 4 pi over 3. Now, the neat part about the TI3, TI4 is you can do second enter to bring up the previous entry. And once I do that, I can arrow over. Instead of 2 pi, I'll put 4 pi in there. And that gives us 3. Now if I do second enter, and then second enter there, and then second enter one more time, that brings up this one. And I come over here, or you can just type this all in brand new, and change 2 pi to 4 pi. And that gives us 3. Since both of them give us 3, then both of these check. And those are our answers.